Then safety practices in maintenance of oil filled EHV cables. So you will be presenting, right? So paper number 7.
Good afternoon, everyone. Myself Jadhav from Tata Power. I am working in Tata Power for last 12 years, and I am working in this cable maintenance department. So I am here to share some best practices to maintain what we do regularly for maintenance of old PLC cables, EHV cables. My team members, Sanket Benkel is right now not available. Harshad Kuwade, just he gave one presentation, and myself Abhinav Jadhav. I will just share a small history of cables, what we use in Tata Power for last 100 years. Previously, we started with 6.6 kV network. We ran cable from Parel receiving to simplex mill. It was the first consumer in 1915. Then 22 kV cables, it came in, it was introduced in 1922, and later this 11 kV and 33 kV network was introduced in 50s. Now EHV cables. First EHV cable which was laid was 110 kV 3-core gas filled cable. Right now we are just discarded this cable 5 years back, but we are using this cable since 1955. 110 kV 3-core oil filled cables. We are still using this. These cables were introduced in 1961. They are still in service. We are maintaining the oil filled cables. We are maintaining the spares which we have kept preserved properly in an AC container since 1960s, 70s. After the project was initiated, some spares were stored with us. Then 100 kV single core oil filled cable was introduced in 1987, and then 220 kV oil filled single core cable was introduced in same 1987. Then this 110 kV single core XLP cable and 220 single core XLP cable were introduced in later 1999. These are types of cables. Gas filled cables right now we are not using. 100 kV oil filled cables and 110 kV 220 kV XLP cables we are using. Total network of cable is 174 kilometers. Oil filled cable network we are using. This is a structure of oil filled cable. Here we can see this oil ducts, 3 oil ducts, and these are 3-phase core. This is the copper conductor, and this will be the paper insulation of this all 3 cores. Here you can see the lead portion, which is used for protection, it is mechanical protection as well as for grounding, grounding purpose. Then the outer sheet. Now 110 kV oil filled cables, outer sealing ends. Previously, we are using this porcelain sealing ends were there. These are still in service. This sealing were prepared at the time of project execution, but right now they are still in service. We are maintaining it properly. This oil, here you can see the oil tanks. These oil tanks are used on either side of the cable end, which maintain the oil pressure. To maintain the oil pressure of 1.2 to 1.5 bar by using this oil pressure tanks. And here you can see a pressure gauge panel. Here we get the pressure gauge are installed, and we can monitor the pressure of these cables. Now in maintenance practice, this oil leaks, the major portion of maintenance is to maintain oil leaks. The oil leaks are majorly due to the wear and tear, and majorly it comes from the plumb portion of the joint, or if it is damaged by some other utility or due to external damage. This can be this is reduced by this external damage cases. We have to reduce by proper monitoring for properly doing patrolling and patrolling of the cables. The best practices for maintaining oil field cable is patrolling and safeguarding of EHV cables. Various methods are applied. We use foot patrolling. The patrolman will go through the route, and if ever there is any excavation work is in progress at that location, he will inform us, and if required, if the cables are on the same route or cables are exposed, we will have to safeguard that cables. Then bike patrolling is also introduced. Bike patrolling, the person will go on bike and cover the complete route in both day and night shift. GIS, this geographic information system is utilized, is introduced, in which our cable data, cable routes are mapped on Google Map, and the actual and DTS system is provided to the bike patrol. So we can track the person, patrolman, that whether he has covered the route or not by this tracking system. Then FDC app is utilized. This FDC app is to collect the data of the actual, collect the data from the site. If the patrolman goes on site and he sees any activity, he will enter the activity location, and immediate SMS will be generated, and it will be shown to the concerned engineer, and he will take the necessary action. Patrolman can also add these videos and photos on that app. Online oil pressure monitoring. This previously, what I have shown you in the previous sheet, the oil pressure was monitored on the oil gauges installed at the both ends of the cable end. So it was the oil pressure was can be monitored only by going there and see the reading. Every day morning, our patrolman would go at all the locations as per the line given to them, and he will go and see the reading. He will check if there is some. He will monitor the reading. If there is no abnormality, he will note down the reading, and next day will come and note down that reading is in the register. But to know the real-time monitoring, we have introduced this system. We have installed these transducers at parallel to the oil pressure gauge. Due to this, we can see directly the oil pressure on the mimic panel in the control room itself. So suppose in case of any tripping or some, we have to send our patrolman to see the reading at both the ends. If there is any tripping, he will go and see the reading. If there is any oil drop, then we can see that the cable may be damaged or something like that. So by seeing the oil pressure directly on the mimic, we can directly clear the section, and we can clear the section, and the cable can be charged. This barcode system is prepared. This patrolman, when he goes on site to check the reading, he will scan this document with a mobile app. He will enter the oil pressure, and the pressure notification will be generated. A mail will be automatically generated, and it will go to the concerned engineer. that thing, this is for tracking itself. Suppose some petrolman will not go there and not see the reading, but because of this we can track at what time he has taken the reading, at whether he has gone or not. Previously that they used to go and give the reading after the next day they used to write in the book. So this is for the tracking. Then oil filtration and oil pumping. We have these oil pumping plants. In case of any oil leakage in the cable, we pump the oil from this plant. We have to connect this plant to the oil pressure tanks used on both the side of the cable, on either one side of the cable, and we can pump the oil pressure and maintain the oil pressure in the cable. This is fire protection system, fire protective coating used on the cables. This is for in the basement of the cable where there is a chance of fire, and there are many cables, and due to this fire the nearby cable may get fire. So this fire retardant paint is applied on the cable to protect the cables. Also in the next this aerosol fire protection system is installed in the cubicle of the oil pressure tanks. So in case of any fire, this will operate and extinguish the fire. So you can see the basement area where all the cables are painted with this and this. Sorry. This is the tunnel which we are used for laying cables. This is from one of our substation in BKC, where all the cables, in-cover cables are laid on the tray and it is brought to the substation. In all the receivings, we have protected our cables by using this fire retardant paint. Then EHV cable safeguarding activity. There are many infrastructure activities in the Mumbai area. So many new trains activity. This metro work is going on, and at many locations we have to protect our cables. It is not possible to shift the oil field cables. So we have to protect by using the possible way. Here we can see that. Here we can see these channels are installed and our cables are at this location. We have used these strings, and even sometimes we have to use the cranes for lifting these cables, and then we have used these channels for holding the cable. And this will, at many stations in metro station works, this type of work is done. This is at the metro piling work at Lokhandwala. Here our cables are there, and there is piling work adjacent to the cables. So there also we have supported this by using these channels. See, in this picture you can see it clearly. We have placed this channel, and these are our cables. And this is the raft made for the pillar. So we have protected our cables. And after this completion, then we have removed this support. Unless we use of neon tester and grounding rod. This 100 kV. This is the live contact ceiling end where we can, when in case of outage, any outage, we can directly go and touch the cable, start work. So we are using this neon testers. This is several 100 kV line. We have neon tester for all 33 kV rated, 110 kV and 220 kV rated. All three different specifications. we are using this extensible rod as per the size of the ceiling head. And discharge rod also we are having the same length discharge rod. Neon tester is used under dry conditions. Extensible rod rod according to the voltage is used. Neon tester is checked for proper functioning of LED before use. It can be used by by pressing the knob. If the beep operates, then it is seen that it is working. The positive confirmation can be done by touching it to the live equipment also. Then lockout tagout system. Here we use this lockout tagout before any outage, before doing any work. On either side of the cable breaker end, this local hasp is used. This is called hasp. This is provided on the breaker isolator, and all the parties who are going to work on this can use their individual locks on this. At this location 6 people can use this lock. Their locks. E-loco system is also introduced. Suppose the isolating ends are in kilometers. Suppose we are doing some work on Mira Dharavi line. So it is not possible to go and check in the Mira. So E-loco lock system are also used. Repair of 400 kV oil. This is a slide where our team has gone to NHPC for repair of this 400 kV oil leak. This is just a photo. Our oil expert jointers oil field expert jointers are available. And we are giving services to NHPC. We have given services to NHPC. Puri in Kashmir. Last 2020 we are gone for repair of this cable at NHPC. Because there are no other jointers available for working on these oil field cables. Even though this 400 kV network is not there in Tata, our jointers are expert, and we have attended these leaks 4 to 5 times in a week. Last year, in this pandemic, we have gone to Uri and attended a leak. This is not a picture. This was in 2020. 2020, we have attended the leak below the ceiling end. It was 1 meter just below the ceiling end, and in ground level, when the cable is horizontal, it is possible to maintain the oil pressure. Suppose the oil pressure is lowered, and then we can do the repair the leak. But at that location, we had attended the leak at the pressure of 7 bars, because this both the level difference was there. Switchgear end was 70 meters down, and this switchyard was 70 meters up. So oil pressure cannot be reduced. So this 7 bar pressure was there, and at that pressure we have attended this leak. That's all. Thank you.
Questions, please.
No question? I have questions. Please.
Very interesting paper. First of all, you have lastly mentioned that oil cable, oil leak in 400 kV. And how will it 7 bar oil pressure? What is your leak repair system or procedure?
Sir, the leak it was at 7 bar pressure. It was below 1.5 meter below the ceiling end.
Now, do you seal the leak first and then repair and then allow the oil to flow?
Yes, we have to seal the leak, and then the normal oil will flow in the cable.
Okay. What is neon tester?
Neon tester is for checking the liveness of cable.
Why it is called neon?
Neon, it
was a neon lamp.
neon lamp. It is just like a neon lamp, or it is just like a tester.
Sir, just 1 minute. I would like to take some 1 minute.
Yes, please.
See, neon tester, as you mentioned, you have mentioned that for different voltages
Yes.
level, you have different neon testers.
Yes, yes.
Now the problem, now what I would like to suggest is, there is neon tester available, which is a range of 100 volt to 245 kV, and that also non-contact type. Then, and price is also very less. It is hardly 35,000 to 40,000.
No, suppose every time we have a work of 100 kV, we carry that. Unnecessary carrying this that may damage, and this
We
because
will
this
100 kV.
11 kV, 33 kV neon tester
No, so
not that cost.
Hey, what I said is, see, what I said is,
It's
so there are non-contacted neon testers available,
Yeah,
and
non-contact.
it has a voltage range of 100 volt to 245 kV. You can imagine the range. Yeah.
So,
The same neon tester can be used anywhere, any voltage.
Is
Then
there
why
any-
you need a separate neon tester for different
Is
voltages?
there any weight
Yeah, please.
restriction? Any weight
Sir,
restriction?
It's about usage of neon tester. We have a practice of using neon tester.
Yeah.
And currently we have started using those neon testers which you are talking about.
Ah.
So only the thing is we already have neon testers of different
So
voltage.
stock column khatam kar raha hai, right?
हाँ, हाँ.
Okay.
But
Fine.
the main motto is to use the usage of a neon tester.
Now another question is,
See, neon tester when you are using, so it can use only when you have a single core. The moment you have 3-core cable,
Yes.
and neon tester cannot detect the voltage, so that is
Yes.
a problem.
no 3-core cable.
yeah.
Yes, we are using it in 3-core cable. So you will have to move it on the all 3 cables.
No, when
A 3-core shielded cable,
Yes.
neon tester cannot detect it because 3 phases balance each other. So it will not be able, this neon tester cannot detect it. If it is a single core, it can detect. While it is in the terminal, it can detect.
Then if there is a problem, how do you detect it in that?
So
case?
it cannot be detected with
No,
neon
no,
tester.
we have tried, sir. We regularly use it.
okay, fine.
Right. You have told about the paints, the fire retardant
We
paints.
don't use on cable.
And what are these paints?
What?
Fire retardant paints. What are these paints? And up to what temperature it can sustain?
Sir, it's such about 300 degrees.
Sir, this document I can send it. I have that.
I have that specification, I will send it to several. There is some question, yeah, you said some remarks over there, yeah, please.
Sorry to bother, sir. Actually, sir, that your point, we don't use this neon tester on cables. Only where the cable
But
termination
the
is done.
question came because it was told that neon testers are used for detecting voltage in cable. That is why I raised the
No, no,
question.
no.
No,
Yeah,
on the ceiling
it is on the termination point. Cable is.
At the ceiling edge. Termination and ceiling.
To identify the cable, we have to do spiking. That's it.
Fine, thank you for the clarification.
Just a passive experience I would like to share about cable damages. In Pune Metro, when they started the work, they approached local MSCDCL office and they told them that the executive engineers who are touching 55 age and they are supposed to retire in a day or year or so, we would like to meet all of them. Metro authorities met them and about 20 engineers of that age were taken on contract immediately after they retired. They knew entire cable network in Pune. I mean, at few places they had to, do underground cabling for 132 kV, which was already overhead, which will come across actual metro route. So it was comparatively very easy for them to know the cable routes as well as to handle logistics behind it. Handling a cable is very, through government authorities is very difficult, but they could get good access because they knew everything. They know what was there inside, they know where is the cable, how to attack it. This is a novel approach. No government authority will do it, but they physically went to office, they located the...
realistic approach.
They immediately they immediately gave 10 vehicles to them, so they were accessible anytime, and lot of problems were saved.
what is the type of oil in oil field EHV?
No viscosity
Oil.
No viscosity. It's
Oil?
a T3788 grade oil.
Okay.
No viscosity.
No viscosity?
Low
viscosity. How much?
That he may not be able to.
So no.
Viscosity is a degree centigrade, is a unit. But how much? But
Sir.
low viscosity.
Sir, electrical engineers may not be having the chemical specification. Right, sir.
Thank you. Thank you very much.
Thank you very much. Thank you very much. Let us move to the next technical paper.